Good morning. This is Miss Luck. Today I'm going to talk to you about another type of transport. So Friday you talked about the cell membrane, and yesterday Mr. Burfine talked about the passive transport. Today I'm going to talk about active transport and really about the roles that proteins play in active transport, the difference between active and passive transport, and then looking at the different kinds of active transport, so using the membrane pumps and what endocytosis and exocytosis is. So turn to page 12 of your packet, and it should look like this. Let me move me over there. It should look like this. And take out your pencils. Let's get going. If this is confusing, feel free to stop, rewind, rewatch this screencast, or hit pause while you take notes. So yesterday, Mr. Burfine talked about passive transport, and he talked about the fact that molecules went from a high concentration to a low concentration. In active transport, molecules sometimes have to go from a low concentration to a high concentration. There might be a time when you were at the US Bank Stadium and the game was over and you were all leaving. Everybody was leaving the stadium, but you forgot your souvenir cup and you had to go back to your seat. You went basically against the flow of traffic in order to get your souvenir cup. So going from a low concentration to a high concentration is going against the concentration gradient. Remember, going with the concentration gradient was going from high to low. So that's what active transport is, going from a low concentration to a high concentration. Now, passive transport, just like the word sounds, was passive. Active requires energy. It requires some energy. So, like pumping air into a tire, requiring some energy to get there, is going from a low concentration to a higher concentration, getting oxygen into that bike tire. The molecule we use to show you it's using energy is called ATP. It's a special nucleotide that's a bit of a rechargeable battery, so it can continue to recycle itself. But that's the energy required in order to get these ions or molecules across a membrane from a low concentration to a high concentration. So we use these what are called protein pumps. Can you see this picture on the top of page 12? Hit pause while you take notes on this. Solutes enter a carrier protein that uses ATP or energy to pump those solutes across the membranes. Notice you've got very few solutes on this side of the membrane and many solutes on the other side of the membrane. Here are these protein carriers that can pump solutes through the membrane. And here's my little molecule of ATP. So using a bit of energy to get these solutes to cross the membrane. It is moving solutes from a low concentration to a high concentration. Remember yesterday when Mr. Burfine was talking about sometimes you've got charged molecules, and these charged molecules are called ions, but they also cannot pass through the cell membrane on their own. And those ions require a protein pump as well. An example of that is sodium, potassium ions, calcium ions. They all carry a charge, and they can't pass through that cell membrane. So they go to this potassium pump, sodium potassium pump, this protein pump that allows them to get through with a little bit of energy. Here's my ATP molecule that gets them across the membrane. Notice there's very few sodium ions on this side of the membrane, and we're pumping them over to where it is high, low concentration to a high concentration. You could say that about potassium, low concentration to a high concentration. That's a real life example of that would be like with our muscle contractions and our nerve impulses. They are moving ions from a low concentration to a high concentration in order for them to work. So now hit pause and I want you to look at these two pictures. We're going to play I Spy. What similarities do you see in these two pictures? What differences do you see in these two pictures? All right, hopefully you were able to see on the outside of the cell there are many ions or molecules. On the inside of the cell, very few. Here we have a high concentration on the outside of the cell, low concentration on the inside. With this picture of active transport, you have the same idea. There's a lot of green molecules on the outside of the cell and very few green molecules on the inside of the cell. So that is a similarity between these two pictures. A difference is in passive transport, molecules move from a high concentration to a low concentration. That's what this green arrow is trying to show you. In active transport, we're moving molecules from a low concentration to a high concentration. But hopefully you also saw the word energy. In active transport, there's energy required to get those molecules to go from a low concentration to a high concentration. You don't have that with passive transport. So, like I just said, going from a high concentration to a low concentration, no energy required. But when you go from a low concentration to a high concentration, energy is required. So there's two types of active transports that I want to talk about, and we refer to them as bulk transport. One, when materials are being brought into a cell. The other is when we're trying to expel or get rid of materials from the inside the cell. Notice in these two pictures how in this one, for example, how you kind of are getting this little enclosure happening, and it becomes a little vesicle that has the same cell membrane as the cell membrane of the cell. And in in this picture, you can see it just fuses with the membrane as it gets rid of material. All right, they have special names. Here we go. Number one is endocytosis. So in your packet on page 12, the first type of bulk transport is called endocytosis. And in endocytosis, the membrane surrounds the solutes and allows them to enter or come in to the cell. They're brought, here's the material, they're brought into the cell. So think of IN, EN, into the cell. Here we've got a little vesicle that's created with the same membrane that you saw with your cell membrane. A white blood cell engulfs a bacteria cell in that way so that we can destroy bacteria cells as they enter our body. The second type of bulk transport is called exocytosis. So on page 12 of your packet, write down the bulk transport number 2 is exocytosis. And that can be defined as a vesicle from inside the cell merging with the cell membrane and getting rid of the solutes, or solutes exit the cell. Can you see here how the vesicle made up of that same cell membrane fuses with the regular cell membrane, and then it just kind of gets it out of the cell? That's what these arrows are pointing to. An example, real life example of that would be insulin being released from your pancreas. So that is your second type of bulk transport. Another example of your exocytosis, might be your nerve cells releasing neurotransmitters. So things like dopamine and serotonin, epinephrine, histamines. When you take an antihistamine, you're preventing the release of that histamine. All right, so I believe this is, here's a picture that Mr. Burfine showed you yesterday, where we talked about simple diffusion of oxygen moving into the cell, simple diffusion, carbon dioxide moving out. Facilitated diffusion. It needs some help. So bigger molecules or molecules that are polar moving through a non-polar membrane need facilitated or some kind of protein to allow it to get through. That was a facilitated type of passive transport. And today I talked about pumping ions through, things going from a low concentration to a high concentration and needing that molecule of ATP. So that's my last slide, but I had one more thought. Nope, I'm going to stop there. Hope this helps. Also remember that vesicles are formed with bulk transport, so moving things into and out of the